All right, this video is completely review. You already should have taken the notes over limiting and excess reagents. If you haven't, that really needs to come first. And we're going to be doing this. This is practice problem number 4 on your limiting reagent worksheet. And the first few on the front already have equations written for you. Just please always double check that they are balanced. But the back problems 3 and 4, you have to write out the equations. So we need to start off with that. You always start off with a balanced equation. It says that sulfur reacts with oxygen to produce sulfur trioxide gas. So we know sulfur is S, and we know oxygen is O. Oxygen is also diatomic, so it needs to be O2. And then we produce sulfur trioxide, so that is a molecular formula, sulfur trioxide meaning O3. Now this does need to be balanced. Since your oxygens are kind of at an odd and an even, you'll have to change both of them, and that will allow you to have 6 oxygens each, and then sulfur needs to get balanced with a 2. So now we have a balanced equation to work with. Now, when we first looked at this unit, your first video kind of talked about recipes. So we really need to kind of think back to that first video. And what I'm giving you here is the fact that, you know, here is your recipe. You need 2 moles of sulfur and you need 3 moles of oxygen in order to create this 2 moles of sulfur trioxide. If you do not have enough of one of those ingredients, then you are not going to be able to create 2 moles of sulfur trioxide. So think about a recipe that you have at home. Okay, if you need 3 cups of flour to bake a certain cake and you only have 1 cup of flour, then that limits how much cake you can make. It's not going to make as big of a cake as the recipe says, or you know, won't bake as many cookies as the recipe said, whatever it is. So they've given you here 2 of your ingredients, the sulfur and the oxygen, and they're telling you that you have 6.3 grams of sulfur sitting in your laboratory and you have 10 grams of oxygen sitting in your laboratory. Which one of those is going to limit how much product you're allowed to make? Which one of those is the limiting reactant, because they're both on the reactant side? So what we need to do is, you know, really at this point you just need to pick one of these, and it doesn't matter which one you pick, because either one is going to lead you to the right answer. So let's just say that we start with the 6.3, because that just is the first number in the problem, so that's what I'm going to start with. So I have 6.3 grams of sulfur. Now I want to know, if I have 6.3 grams of sulfur, how much oxygen do I need? Because I know how much oxygen I have. I have 10 grams sitting in my laboratory. How much oxygen do I need if I use up all 6.3 grams of sulfur? And that's going to tell me if sulfur is my excess or my limiting reagent. So to do that, we are going to have to go through the process of converting grams of sulfur into grams of oxygen so we can compare what we need versus what we have in our problem. And so we know how to do that. We've been practicing those already. We are going to have to convert to grams of oxygen, so that means I need to get rid of this grams of sulfur. And we do that with a mole to mole, sorry, not yet. We do that with a molar mass. Sulfur's molar mass is 32.1 per mole, so there's my 1 mole. And again, this is sulfur, grams of sulfur. And now I can get rid of my moles of sulfur because I don't want moles of sulfur. I can convert to oxygen. The only way that you can convert from one chemical to another chemical is with a balanced equation and using these mole to mole ratios. So I have a 2 for my moles of sulfur in my balanced equation and a 3 for my oxygen. So that's where those numbers come from. That's why you have to have a balanced equation. Now we don't want to stop here at moles of oxygen because the problem gave us grams. Now if they would have said that you had 10 moles of oxygen, then we could have stopped at this point and went ahead and calculated it. But we need to get to grams so that we can compare grams with grams. So moles of oxygen needs to go away, and we want to convert to grams of oxygen. So we need to know the molar mass. Oxygen is 16.0, and so in order to get to, you know, the right amount of grams, I am going to have to do 2 times 16.0. And so there's my 32. Okay, I need 32.0 grams of oxygen. All right. Now, if you calculate that all out, you're going to take 6.3 and you're going to divide it by 32.1. You're going to multiply it by 3. You're going to divide it by 2. And you're going to multiply it by 32.0. You're going to end up with 9.4 grams of oxygen. And it's actually a larger number than that, obviously, but I am stuck with two significant digits. That's where my 9.4 came from. So this is how much I would need. I have 6.3 grams of sulfur. If I use up all 6.3 grams of sulfur, I only need this much oxygen. Do I have that much oxygen available? Go back to your problem. I have 10.0 grams. Do I have enough oxygen? So yes, you have enough oxygen, right? You actually have 0.6 grams more than what you need. So that means because you have more oxygen than what you truly would need, oxygen is going to be in excess. And that means that sulfur is your limiting. All right? So that's how you do that. You always think about what you're calculating over here is this is what I need, and then you have to go back to the numbers they give you in the problem. Do you have enough of that particular ingredient? So now that we know that oxygen is our excess and sulfur is our limiting, we can solve the second part of the problem where it says how many grams of sulfur trioxide will be produced. Remember that the amount of product that you can make is limited by your lowest amount of ingredients. Okay, my lowest amount, my limiting amount was sulfur. So at 6.3 grams, that is the one that is going to run out first. Now, if I have 6.3 grams of sulfur and it's going to run out, that's going to control how much product that I can make. And so I want to find grams of sulfur trioxide. So this goes back to, again, things that we already know. We can convert grams of sulfur to grams of sulfur trioxide. We just have to go through all of our steps again to convert those. So we'll have moles of sulfur and moles of the SO3. Sulfur in your balanced equation was a 2, and SO3 was also 2 moles. And then we have to do a molar mass, and that's always per 1 mole. And if you add up all of the 32.1 for sulfur, 3 times 16.0 gives you 48.0, so you're looking at 80.1 grams of SO3. Now these are going to cancel each other because they reduce down to 1. So you're taking 6.3 and you're dividing by 32.1. You multiply by 2 and then divide by 2. You know, that step pretty much cancels itself out. But then you do have to multiply by the 80.1. Now you are stuck again with just the 2 significant digits. I get like 15.7205, okay, this big number. So that is going to round to 16 grams of SO3. That is how much I can make of my product. Again, the amount of product that you can make, you always have to use your limiting. Use your limiting one to calculate your product. If you don't use the limiting one, you use the excess one, then really you're going to have run out of an ingredient. You won't be able to fully make that amount of product. So you always have to use your limiting one. I hope that helped to see another problem, but please ask questions if you don't understand. There is a lot of math involved with this. Please double check balanced equations and, of course, significant digits.